All right, so we are looking at graphing inequalities, linear inequalities, I should say, linear inequalities, part 3 of 3. So we're going to wrap it up all here. All right, immediately you should notice something quite different. I'm looking at these examples, and I see that they're not necessarily in the whole y equals something times x plus something. So I'm actually going to use a slightly different technique. I'm going to use the x and y intercepts. And what do I know about that? Well, I know that when I have the x-intercept, that y equals 0. And then the other part is just, I don't know. When I have the y-intercept, that x equals 0, and the y part, I don't know. So I already have half the information for those. Let's start with, I don't know, the easy one. So if I'm looking at this more like an equal sign, like 8x minus y equals negative 4. Let's start by making one of the terms 0. Well, the first term, 8x, if I were to make that a 0, that's almost like covering it up because it's this term right here. It's almost like saying if that makes a 0, then all I have is negative times y equals negative 4. Okay, so negative times y equals negative 4. Let's see if I can show something here. So what I'm trying to say is if this goes away like that, then you have negative times y equals negative 4. Well, what number would that be? Well, that'd be negative 4. So what that tells me is that, or it wouldn't be negative 4, it'd be 4. That tells me that y equals 4 when x equals 0. So 0, 4 is on the line. Well, let's do the same thing for the other point. So if we start with 8x minus y equals negative 4, let's make this y term go to 0 and to find the x-intercept. So again, it's like negative 1 times 0 disappears. Okay, so if that's going to disappear, what would be left over? We would have 8x equals negative 4. X then would be negative 2. So that tells me that when x equals negative 2, y equals 0. So y equals 0, x equals negative 2. There's my point. Now I have a line, and in fact, I could pretty much see the pattern here. It looks like we have a slope of positive 2 working its way all the way through the line. So now what do we do with that? Okay, you see that this is not equal. It's not equal, so that means this is going to remain a dotted line. I'm going to go ahead and draw that freehand, but it's a dotted line. Now I have to test a point. I love testing 0, 0. Let's plug that in and see what we got. That would be 8x minus y is less than negative 4. So I'm going to plug in 0 for x and a 0 for the y. Let's see what happens. I'll have 0 minus 0 is just 0, so 0 is less than negative 4. That is not true because the negative is going to be below 0. So the 0 in here, the 0, 0, is false. That means this side on the other side of the line is true. So I'm going to shade that. There we go. All right, so not too hard. Pretty doable there. But let's take a look at number 8. Same kind of idea, same very, very similar action taking place. Numbers not so friendly, but that's okay. So again, I'm going to use the whole y-intercept thing. In fact, I'm going to erase some of this stuff over here just to give myself some space. Boom, there it goes. All right. So I'm going to be looking at the x and y-intercepts. Let's say I were to do the x-intercept. That means that y equals 0. So what would we have? That would be 2x minus 0, because y is a 0 there, is greater than or equal to 3. Well, that would have 2x is, well, let's just look at the equal. 2x equals 3, because we're looking at the boundary line. Divide by 2, and you'd have x equals 3 halves. Okay, so x is 3 halves when y equals 0. That's at 1.5, or like 1.5. Let's do the other one for the y-intercept. So if I'm doing the y-intercept, that means that x equals 0. So I'm going to have 2 times the x value is 0 minus y is equal to 3. Okay, so we got 2 times 0 minus y equals 3. Let's multiply. The 0 is going to disappear because we don't have to write it. And negative y, if I multiply both sides by a negative 1, I'd have y equals negative 3. So that means my y-intercept is at negative 3, right there. So we have these 2 points. And in fact, if I were to go up and over in the same fashion, this, I think, is what I would get. Pretty close there. I'm kind of approximating it, but going pretty close. We want some decent accuracy. All right, so there I go. There's my dots. Let's see what I got from here. Okay, so I got the boundary line is equal to, which means it is solid. So I'm going to draw a solid line through this. Oh, that should be up here. That's why it looked a little bit off. I was wondering. There we go. So there's my solid line. So now I want to shade, so I'm going to test. Let's test 0, 0, just like usual. That would be 2 times 0 minus 0 is greater than or equal to 3. All right. Then we'd have 0 is greater than or equal to 3. That's actually false. That's not true. So this side is false. So we got false. Whoa, what's happening there? What's going on? We're jumping the gun. False is not shaded, but true is. True is shaded, false is not. Awesome. I'm going to do, let's say, one more. Let's take a look at what we got coming up and pick one of those. All right, how about one of these? Numbers look quite big here. Not really that huge, but still very doable. Let's do number 10. So we're looking at number 10 here. So the first idea is it's not already in slope-intercept form, so I'm going to just use intercepts. There's other ways you can do this, but I'm going to use the intercepts, x and y-intercept. So if I'm looking at the x-intercept, that means that y equals 0. The other number, or the other variable, I should say, is going to be 0 when you're on an intercept. So x-intercept, that means that I'll have 9x plus 2 times 0. We're looking for the boundary line, so I'm going to look at equals 10. All right, so that's just going to give me 9x equals 10. And if I do some dividing here, then I got x equals 10 over 9, which is just over 1. It's like right there. Okay, let's look at the y-intercept. That means that x equals 0. So I plug in 0 for x, that would give me 9 times 0 plus 2y equals 10. This actually does divide evenly. Y is going to be equal to 5. So, ooh, did I do that last one wrong? X equals 10 over 9. I did do it wrong. You guys are probably shouting at the screen, saying, Mr. Butler, what you thinking? That's on the x-axis. The one that I'm about to do now, y equals 5, is on the y-axis. And there's my line. I'm going to cheat a little bit here. I'm going to go ahead and draw this line straight through. What we do want to keep in mind is that it is less than, not equal to, which means we're going to use a dotted line to go through those 2 points. Why is it dotted again? Well, it's because this piece right there is not equal. Therefore, we have the dotted line. Okay, so now we got a test. Test, test, test. Let's test 0. That would give me 9 times 0 plus 2 times 0 is less than 10. I think that's true, but just to double check, we simplify, we got 0 plus 0. That's 0 is less than 10. That is definitely true. Okay, so if that's true, that means that this side is true, and we're going to shade all that. The other side would be false and would have been empty. All right, so there is quite a bit of examples there, plenty for you guys to look at. I hope that these videos were helpful. Remember, they're also on YouTube as well. Where was that at again? Well, you better write this down, youtube.com/user/PVHS Butler. Why? Because I'm the butler. All right, that's it. Sounds good. See you later.